Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be static electricity. This is quite a simple and fun chapter, no formulas, just draw a little bit of pictures, seeing some pictures, deducing some patterns. Static electricity, there's two words, that static means not moving, and also electricity, which talks about movement of electrons. So electrons that don't really move around. So how does that work? In a conductor like metal, so the electrons are free to fly from one end to the other end, but in say insulators or non-conductors of electricity, the electrons will just stay in that spot. They can move from item to item, but they will mainly stay at a particular spot. And this creates a certain effect, which we'll be looking at in this chapter. So how does electrons fly from one end to the other end? So of course, we used to have studied atomic structure in chemistry in the earlier topics. An atom is made of a nucleus, which forms certain particles like protons, neutrons. On the shell of the atom, do note that they do not orbit, they do not fly in a circle, they just hang around at the periphery, means at the surface, at the shell, okay? Electrons are on the outside. So when there is friction or anything like that, rubbing action, some of these electrons will be pushed out of its position and it goes somewhere else. And you know that electrons and protons, they are charged particles, but in this case, we are only so focused on electrons. So we measure the charge, the size of the charge by coulomb, the unit is coulomb. Each electron has a charge of 1.6 times 10 to the power of 19 coulombs. And each electron has this amount of coulombs in the negative charge, and the proton has this amount of coulombs in the positive charge. And like magnetism have been exposed in your primary school, your earlier education, that like charges repel and unlike charges will attract. So it's the same over here, very simple. So they exhibit this thing called the electric field. So it's a region, it's an area where the electric charge experience a certain amount of force. So what does it mean? So if you hold a test charge where a little ball of a certain known charge, let's say it's positive charge, then you hang it freely, let it dangle freely, and then you move towards an item. If it gets attracted, it's the opposite charge. The item has the opposite charge, it gets repelled, then that item has a like charge. And this is how you would depict it in your work, your school work. Plus sign always go out and minus sign always come in. So how do you remember it? It's pretty easy. Let's say you are extroverted, you're plus sign, plus energy, you always want to go out of the house. And if you're minus sign, you're very introvert, just want to stay by yourself, you just want to come into the house, so always draw inwards. And draw in directions like that would be good enough. And how do they interact with each other will be as such. The plus sign will go out and enter the negative sign. And what happens if it is the two like charges, they will repel each other, both of them want to go out, so they will not intersect with each other because they repel. And this is the electric field that they will experience. That's why there is a certain repulsion force. And this attraction or repulsion is also dependent on the distance. So closer they are, they will feel more of this force, be it attraction or repulsion. So how are things electrostatically charged? More often than not, it is via friction. So if you are in a mall, sometimes you touch the railing, you get zapped. Or you're walking, suddenly you touch a friend, you zap your friend. How do you try this out? You step far apart with your friend, and then you walk certain distance, getting closer and closer and closer, maybe a good 20-30 meters, and then you touch each other. Then likely you get zapped. And to get a better effect, you drag your feet. So friction will create a lot of charge in your body, and then once you touch a friend, the discharge will happen. So this is what happens also in the air. A lot of moving parts, a lot of moving particles pushes out a lot of electrons and passes to somebody else, okay, to the lower end of the clouds. And the lower ends of the clouds get a lot of electrons. Once it gets too heavy and it induces the ground level to have a lot of positive charge. It pushes away electrons in the area, and then once it gets strong enough, a discharge happens, and that's how your lightning is produced. So like mentioned, through friction, electrons are being pushed out. So I know most of you watching, you may be chemistry students, you may want to understand or how much of it is a plus ion and things like. You don't have to be too emotional about it. You just have to know electrons come from where, goes to where. You don't have to count how many moles of electrons. You do not have to account for any of these things. Okay, and here is a table. The top, more tendency to lose electrons, bottom, more tendency to gain electrons. Oh, okay, also in the topic of this shopping mall. Usually it's air conditioned, and in the colder air, it's usually drier. And as such, drier air has more charge. They contain more charge in the air. They have to encourage a lot of building up of charges. If there's a lot of moisture in the air, the water molecules easily attract these charges, be it like a positive charge or negative charge, and they'll carry it away. So humid air removes a lot of static electricity from materials.
So as you can see, my hair has returned to its factory settings thanks to the humidity here. I'm not complaining, I like it.
These are for all those, you can see all these items are non-metals. They are non-conductors of electricity, insulators, you may call it also. So they are charged by friction, by rubbing. Okay, so metals can also be charged as well. And one of the way to charge one conductor will be if you hold a negative charge rod to a ball. And of course, the stem here is insulated and does not conduct electricity. And because the rod is negative, it attracts the unlike charge, the positive charge, to one side and pushes the like charge, the negative one, on the other side. If you touch it, of course not very recommended. So usually what you call is to earth it, means you connect a wire, the electrical wire that conducts electricity, and push it to the ground. Okay, the ground is like a giant tank, okay, that you really don't have to go and account for how much electrons the ground has and all that. You don't have to, just have to know that they escaped somewhere and let it be. Okay, that's done deal. So it's earthed to the ground, the earth, alright, and they're gone. Then once the electrons flow out, you move the negative rod away. Now the metal sphere is positively charged. So it's the same as if you put a positive rod, then you attract the unlike charge negative, then positive on the other side. Then if you earth it, this time is different. The wire will pull electrons from the earth upwards into the metal ball, and remove, then you get a negative charge ball. So you see, it's just identifying patterns. This is charging one ball. You can charge up two balls. So both are in contact, positive rod, then attract unlike, push away like, and you separate and remove. Then they are charged in the opposite charges, equal size amount of charge. And same, you can also use the negative rod, then unlike here, and the light is away, then you separate and remove. It's the same. Okay, so some examples of this electrostatic charging in our everyday lives, like mentioned in the shopping mall example, lightning example, okay, transferring of fluids and dry materials. Okay, so when dry materials, they flow through holes, there's a lot of friction, a lot of electrons are lost and passed to somebody else. Okay, once they contain enough charges and have this sudden outlet spark, this outlet discharge, when the electrons suddenly rush out, that sudden rush of a huge amount of electrons will cause a lot of friction, and that creates a spark and can start fires. And if the material that you're transferring is flammable, it causes fire or explosion. And this occurs a lot in trucks carrying all kinds of goods. So it's common that trucks have this little chain that helps to earth down all the charges, a metal chain, right? Usually dangled to the ground. So any spare electrons that's running around gets pushed to the ground. Airflow across planes also create a lot of charge. Then planes have these static discharge rods that discharge the spare charges into the air, and this is especially important for mid-air refueling. So a refueling aircraft is pushing fuel in the air to another flying aircraft. Spray painting as well, they are charged up when they exit the nozzle. So all of them have like charges. They push against each other, they repel each other, so they spread out and coats the item evenly. Precipitator, electrostatic precipitator, so gas like smoke, okay, is given a certain charge, usually like negative. There's a wire that charges these particles up, and the plates are positively charged, so the smoke particles will be attracted to the plates. The cleaner gas, okay, will be free to move, and these plates will be periodically tapped to push down all the dirt. Yeah, and that's about it. You can see that it's actually quite chill, quite simple. Let's go on to some sample questions. So two insulated uncharged metal sphere XY in contact. So you put a positive rod there. Okay, after this action, X as a negative charge. So the charge on Y is, of course, D positive, but the same charge as on X. because unlike attract and like will be repelled away, these equal amount. Okay, stationary electric charge. Negative charge is on an electric field, experience a force this direction. What is the direction of the electric field? So because the negative charge wants to go to the right side, which means to say the right side contains positive charge. And positive charge is extrovert, right? So-called extrovert, they point out their arrows, so points from right to the left, horizontally to the left. That is question 2 will be this. Sphere X has positive charge and metal sphere is uncharged. So X move close to Y, does not touch. Y is then Earth, then X is moved away. So what's the final charge distribution? So positive go near Y, the unlike will be attracted. Then Earth means to say that there is electrons flowing upwards instead. So it will be negative charge all over. Isolated metal conductor, X is uncharged. Another isolated metal conductor Y, positive, move towards. What happens when Y is brought close to X? Then some negative charge on X will move to the right, but the positive charge on Y does not move because it's fully charged up already. So the charge does not move. Okay. Refueling of aircraft. Both the fuel and the hose through which passes are insulators, means they do not conduct, so they are going to be charged by friction, right? The fuel passing into the aircraft becomes positively charged, causes aircraft to be positively charged also, which is dangerous. Explain how the fuel becomes charged. It will be this. Okay, passes through, rubs against the side, friction, lose electrons, positive charge. How the charge may cause fuel to ignite. Sudden discharge, okay, of excess charges. When conductors placed near fuel, spark could be produced. A sudden rush produces a lot of friction by the moving electrons. Danger is reduced by connecting wire. Explain this, how this prevents buildup. So this wire to the ground allows spare electrons from the ground to move upwards to neutralize the positive charges, to prevent building out of lots of positive charge. Apart from refueling, state another example. So lightning, due to movement of clouds, buildup of charges in clouds, sudden discharge causes lightning strike, which may cause damage. Glass television, rubbed with soft cloth, screen is positively charged. Then dust particles in the air are attracted to screen. Explain why dust particles are attracted to the screen. You may draw figure if you wish. Usually you just have to draw, right? Just draw first. When particles are near, the electrons are in the dust are attracted to the side closer to screen, unlike attract, okay, causing charge separation in the particle. As negative charge region in the dust particle is nearer to the screen, the force of attraction is greater than the repulsion force, therefore resulting overall force to be attracted to the screen. Okay, next is a student charged glass rod and plastic rod. Glass rod is charged positively, okay, placed on top of balance, so it reads 56.2 grams. So if you put another rod and it is 58.4, which means to say there is a more downward force, right? Which means to say it's experiencing repulsion, right? Which means to say it's a light charge. The plastic rod is also light charge, right? So explain why reading on the balance increases, because plastic rod is a light charge. Okay, state how this experiment shows that there is electric field. So recall electric field is a region experiencing force. Okay, plastic rod is able to exert a force without coming into contact. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!